This would be your typical off-grid setup, so you'd have your solar panel running down to a charge controller. Right in the middle you would have your battery connected. This is a homemade battery using 1850 cells, which are commonly found in vapes or in laptop batteries. It's also what the Tesla Powerwall uses. This battery goes into this controller, which monitors the voltage, current, power, and energy on the battery. This little controller is not necessary, but it's nice to have. Then over here on the controller you can see USB ports, which you can use to power your cell phone or other small electronics. And over here on the right side, this is the load side, which runs over to an inverter. Now, if you're using this off-grid, you can use a non-sine wave inverter, such as this one here. And this inverter will step up the voltage from 12 volts from the battery up to 110 volts AC current, which you can then use to power any electronics such as your TV, gaming consoles, computer, etc. To turn it on, you just flip the switch. The monitor will display the current and the usage, and then you can just power your electronics. If you wanted to have a grid tie system, you would have your solar panels with a fuse connected to a grid tie inverter like this. And this will step up the voltage from 12 volts up to 110 volts, which runs down a cable just like this, which then you can plug in directly to any wall outlet in your home. If you wanted to monitor how much power you're actually putting back into the grid, you could get a voltmeter like this, plug the grid tie inverter into it, and then plug the voltmeter into the plug in your home. And then you can see how many kilowatts per hour you're putting back into the grid. Now, if you wanted to use a battery as well as a grid tie inverter, then you would have a setup that looks kind of like this. So you'd have your solar panel with a fuse connected to a grid tie inverter like this one. This one here is a pure sine wave inverter, but it's a European inverter, so it steps it up to 240 volts rather than 110. This one gets much hotter, so it's got two fans here. And in order to make this work, I had to make this cable. This cable is commonly referred to as a suicide cable, because you could potentially hurt yourself or or cause fires if you don't know what you're doing. So I wouldn't exactly suggest doing this, but if you wanted to try it out, you could. Just be very careful. Now, since this is going at 240 volts, you need to step it down to 110 volts, which is usable in the US. If you're in Europe, then this inverter will work just fine. But if you're in the US, you have to step it down, so you have to use something like this to step down 240 volts even lower to 110 volts, which is now usable on the power outlet. And then you can plug this into a voltmeter and then into the wall outlet. Now this other cable here plugs into your wall outlet, and at night when there's no sunlight, it will output a signal to these two ports, which you connect your battery to. So during the day, your battery will be powered by the sun, and at night this inverter will pull energy from the grid, charge your battery so you can use it in the morning. Or so you can sell it back, kind of like the Tesla Powerwall. Now some of you might be wondering what's the difference between this inverter here and these two inverters. The difference is that this one here is a non-sine wave inverter, so this one is a modified sine wave, and these two over here are pure sine wave inverters. What this means is that these you can actually plug into a wall outlet and not have to worry about it. Additionally, they work a lot better with electronics that have motors. So if you're using it to power a fan or a cooler or anything that has a motor, then these will work a lot better. If you use a modified sine wave inverter with anything that has a motor, then you may end up hearing a buzzing sound, or the motor won't run as efficiently as it would with a pure sine wave. So once again, you probably only want to use those for off-grid, and then use these if you're going to tie into the grid. So there's the three setups, completely off-grid, grid tie inverter, which you can plug in directly to a wall outlet, which is the most simple way to do it, and grid tie with a battery backup. So if you wanted to use multiple panels, then you would connect them in parallel. So all of these are 12-volt panels and they're all connected in parallel. So in order to connect things in parallel, the voltage will remain the same, but the wattage will go up. So here you can see the negative ends are all plugged in together into one cable, and all the positive ends are plugged into one right here. On the positive side, I have a 20 amp fuse, and this is used for backfire. So if for some reason the inverter backfired, then you wouldn't destroy your solar panels. And then these cables here would be the ones that you would plug into your grid tie inverters. And then you could simply plug in the grid tie inverter into a voltmeter like this, and then you can use this voltmeter to help you monitor how much power you're putting back into the grid. So that is basically it for this video. If you guys found it helpful or informative, please remember to like, comment, favorite, or share it. Consider checking out some of the links down in the video's description for all the items used in this video. Anyways, as always, thanks for watching guys, and I will see you next time.